JUMP Math's mission is to enhance the potential in children by encouraging an understanding and a love of math in students and educators. The JUMP program, Junior Undiscovered Math Prodigies, developed by John Mighton, aims to close the gap between highest and lowest achieving students by enhancing their confidence in math skills. The JUMP Math program is designed for students of all abilities in grades 1 through 8, including students experiencing mathematical apprehension or difficulties.
An average JUMP classroom actively involves students in whole class lessons for around 4 to 5 days a week, using a guided discovery approach that collectively engages children in their exciting discoveries. Each math concept is broken down into small manageable steps where the level of difficulty is slowly increased to enable independent practice, while the teacher provides guidance, feedback, frequent assessments, and explicit instruction throughout the process. JUMP Math is recommended by the Canadian Language and Literacy Research Network as a program that offers educators complete and balanced materials, as well as training, to help teachers reach all students.
In terms of how JUMP Math can be used in the classroom, I'm going to give you an example of a 5th grade lesson on perimeter. The first step may be to have students calculate the perimeter of a simple L shape made up of 3 squares, each side measuring 1 unit. Some students may spend more time getting comfortable and counting the perimeter correctly. For advanced students who work at a faster pace, more challenges can be layered on. As a teacher, you can ask questions like, what happens if you add a square to that shape? You can also say, can you do it without changing the perimeter? Can you create a shape where the square will reduce the perimeter? Or you can introduce other shapes with multiple sides missing or give examples of lengths in the thousands. These mathematical concepts are further supported and explored by the worksheets within the Grade 5 JUMP Math workbooks. By incorporating these questions and lessons, teachers can overcome the challenges of reaching students on multiple levels simultaneously. So those students that need extra time, as well as those students that are more advanced, can all learn the same concepts and have the teacher's support.
The extensive materials designed for the JUMP program form the core of the program itself. Lesson plans cover the full curriculum, including ideas for contextualizing mathematical concepts, questions for formative assessment, problems and challenges which allow students to develop concepts, investigate, practice mental math exercises to develop their computational fluency and automatic recall of facts, and includes extension questions for students who finish their work early.
Burton 2010 note that students master new concepts and skills by practicing engaging games that make math fun and enjoyable. This is an example of one of the games in the back of the teacher's guide for grade 5 level. It's a Sudoku warm-up, and it enables students to practice their math skills in a fun and engaging way.
There are several research studies which have examined the JUMP Math program. These have occurred in Lambeth, England, in Vancouver, and in Ontario, Canada. The most significant study occurred in 2011 and was conducted by Solomon, Martinussen, Dupuy, Gervin, Shaban, Tannock and Ferguson. These researchers found significant positive effects of the JUMP Math program on children's achievement scores for the mathematics fluency and calculation subscales of the Woodcock-Johnson 3. 18 schools with similar SES and regional assessment scores in reading and mathematics were selected from a rural school board and were assigned to either JUMP Math or an equivalent program. Grade 5 teachers received training for their programs, and students were taught for 5 months with fidelity to the programs monitored by researchers. Data was collected before and after the intervention from 165 JUMP students and 107 control students of equal gender representation. The study examined effect size, which is a simple way of quantifying the difference between two groups, by emphasising the size of the difference rather than confounding this with the sample size. An effect size of 0.3 tells us that 62% of the control group would score below the average student in the JUMP group. For an effect size of 0.5, 69% of the control group would score below the average person in the JUMP group.
Brasvik and Epstein, 2007, note that students are more engaged and have a better understanding of mathematical concepts when they're receiving direct instruction and ongoing feedback. This also enables them to help self-correct over time, so that they need to check in with the teacher less and they're able to be more excited and more enabled to do the math themselves. While research notes both benefits and limitations to the JUMP Math program, recent studies have shown the successfulness of using the JUMP Math program with students struggling with mathematical concepts. According to Mighton, JUMP takes a revolutionary look at how students learn and how teachers instruct mathematics. The key to JUMP is a balance between step-by-step guidance and encouraging inquiry and problem solving.